Hello, and thank you for joining me. So we're going to go into the workbook for our logic statements and really learn logic operators, and then we'll get into just a brief introduction about how we would use them with pandas. And that will be how we're kind of filter, sort, select. And really, if you get good with these, it will help you get really good with, it'll make you feel as comfortable with pandas as you do with Excel, where you're able to select kind of any data that you want. You can kind of go ahead and get it with logic operations. Okay, and it becomes easier. So with practice. Okay, so let's get started. So our logic operations are greater than, which is, remember this from math class in grade 5 probably, less than as well. In equal to, we do two equal signs as discussed in the classes. We do two equal signs because one equal sign will mean a sign. And what I mean by a sign is I'm going to say the letter A is now equal to the number 42 here. And so I'll be able to use the letter A, the variable A that I've assigned the number 42 as the number 42 for the rest of it. Okay? And you'll get used to that concept. Okay, so not equal to is exclamation equal sign. Greater than is greater than equal to, less than equal to. Okay? So what I'm doing here is I am assigning four variables here that we'll work with, and we'll use our logic operators on these values. So because I'm assigning these, you can delete these values here and just try and use these other numbers here and see if you understand what's going on. They're a little bit bigger, but just to play around and see if you understand these concepts. Okay, so here we're doing A is B. That is false because A is not greater than B. A is less than B. So what we're doing here, so notice this is an interesting feature of a Jupyter Notebook or Colab is that we have the output of this. This is like a function, 1 plus 1 would equal 2. This is outputting, this logic operation is outputting a value, but we're not saving it anywhere. So if we needed to use this in some other way, which is often the case, we're not saving it. So this is just Jupyter Notebook displaying what is in the last line of each cell. I display the code in here. So if I wanted to see that value, I say response is equal to, and I can save response, and I'll be able to use that variable again in my workflows. Here we're going to do, well, A was not less than, so let's go B is greater than C, and that is true. And A is greater than D, so A is greater than D. So here we have 42 and 42. So it's not greater than, it's greater than or equal to. So if we go greater than or equal to, that's true. And the same thing would be true if we did less than or less than equal to. Okay, if we want to test if something is equal to, we do the two equal signs, equal, equal. So true right here. And then if we want to test if something is not equal to, we go A not equal to D. So that's not true because these are equal. So this is not true. If we want to do dual logical indexing, so we want to do more than one or we can do many of these, we want to wrap it in parentheses. So we can wrap the logic statement in parentheses right here, and it doesn't change anything. We just don't have to when it's only one. If we're going to do more than one, we wrap it in parentheses, and we're going to put an and or an or symbol in between these. Okay. So what we're going to do, so this is the ampersand, and the or symbol is this absolute symbol, the up and down symbol, the absolute symbol. I would recommend using those two. You can use and or you can use the written words for everything in Python except for one place with pandas that they do work differently for whatever reason. And it's something they actually do quite a bit. So it's good just not to use them in that. Okay, so here what we're going to go is we're going to see the logic statement and. So we're going to go A divided by B is greater than D, and A divided or B divided by C is less than A. So that's false. So both of these with and, this is true and this is true. So we can use both of that. We can use the ampersand or the and, the written word and, the English word and. Okay, so that was not true. So if we change one of these around, these logic statements around so that it becomes true, so now both of these will be true. Okay, and so we got a true. So now that they're both true, so we just changed around, this one's the same. We changed around this one. Now they're both true. So we get an so that's and is when we're looking for that all meet this requirement. We can do here and again the written word, just to kind of showing this work the same. Okay, we'll go here and then showing or as well. So this is the absolute symbol here or the written word or. Okay. as we get with logic statements. So how we use logic statements most commonly, there's many places that we can use this with Python, but how we use them most commonly is with if statements and to select our data. So we'll go over those two right now. So we'll go over if, else, elif. Okay, so we'll start with an if statement. So Python is great because it follows the written language so well. So we can go if true, if our logic operation is true, print true. Okay, so the way the syntax is going to work, we're going to go if our logic operation and then a colon. So the colon is very important, and then we're going to start the next place on an indentation. So if you notice, if we don't have a colon here and I hit enter, I don't start with an indentation, but if I have a colon, I start with an indentation. So you can get the sense that you'll start to become familiar. If you don't start the indentation, oh, it's like, what did I forget if I don't have this? Oh, yes, the colons right here. Okay, so remember that true is equal to 1 and 1 is equal to 1. So we can either use true, that's what we need. We need to get the output of those values for the if statement to execute. So as we can see here, false or 0, those will not execute. This block of code will not run. So it's all of the stuff that's on the indentation is the block of the code. Okay, so if A is greater than B, we print this. Okay? And we can go dot format. This is one style. This is a little bit of an older style, so I'll show you another style as well. But because if we just put a variable A inside of this, it's going to think it's like a string, it's going to print curly brackets A. So if we want to have a variable go in there and print the value that's in the variable, what we want to do is we want to do dot format, and we're going to say A goes into the first position in the format, second position goes into the second curly brackets. See that? So this was not true, so it did not execute. If it's true, it will execute these right here. So A and then, and this should say less than, haha. Those of you that are using it. Okay. And so what we're going to do here, if we see this as well, we'll do less than as well. We can do this dot format. The more common way nowadays is to use this F statement. You'll still see the dot format just so you know what this is. I use most commonly the F string. So you just put the letter F in front of the string. And when you do that, if you take away this S, just notice what happens. So I have the curly bracket. You can just see the variable is getting printed, the name of the variable, which you often don't really care about. Here, if I put the F string, you can see the curly brackets change color, and then when I put the variable in, what it's going to do is print out the value of that variable. Okay? So just like I said, we can do dual logic statements here. So this is going to be an AND. So both of these have to be true to produce a true value. Okay? And notice that I'm wrapping them in parentheses, and then, which is not true. So if I change that logic operation around for this to be true, because it's not greater than, or sorry, less than, it's less than equal to the value. Okay, so we do that, and we get the printed here, and you can see it's just a lot cleaner to write with this the value in the curly brackets. Okay? So if we go if A greater than B, let's run this. Well, that wasn't true, right? So A is not greater than B, A is less than B. So what we can do is we can do an else statement. We can do, so else is going to catch everything above that was false. So if this is false, we'll do this. So here, less than 40, 42 is less than 47, which we know is true. Okay, so this did not execute. So everything above, you see there's no logic statement here. So it's just if everything above was false, I'll run this. So if this is true, do this, else do this. So it really helps. It's very good English. It follows English kind of syntax in that sense. Okay, so we can do an elif statement. So we can do if this is true, do this, else if this is true, do this, else if everything above was false, do this. Okay. So we can say else, so if it was less than, I can run here and you can see the letters D. Not that it matters in this top ones above. But here we go. So 42 is equal to 42. Okay, so if A is greater than B, which is not, it's the same value, equal to, it's not greater than, we'll do this next one. Else if it's less than, we'll do this. No, it's not less than either. Else, we'll do this. So if it was equal to in this situation. Okay, so let's try one line if statements. Okay, so these are just really handy. You'll use these in certain situations. So say if x is equal to 1, which I'm going to set it equal to 1, let's set it to 0. So if s is equal to 1, and then I run this. So all that's really doing with the one line if statement, I'm just using the print instead of bringing it down below, I'm just having it up on the same line. So it's pretty straightforward. And I notice that I still have the colons here. It's important. So I still have the colons here. I'm just putting the print afterwards up on the same line. Okay, so if I did this with one, though, if this is true, you can see now we put high. So let's see an if statement with an else. This could be a little bit more handy on me. So this I find does not follow good English grammar, but that's fine. So it really just helps saying with bad English grammar. So do this if, so do this, print high, if x equals 1, else do this. So do this if x equals, or if this is true, else do this. So x is equal to 1, so we'll say do this, and it prints high. If x is equal to 0, it will do this value here, not high. Okay, there we go. So just going into pandas quickly, we'll go over a few things, just how we work with pandas. I have the data set on my Google Drive, or sorry, on my GitHub repository, so you can just download it with this extension right here, or URL right here. If you download the data set and you want to upload it yourself, you can mount your Google Drive. If you're using Google Colab, you mount your Google Drive, and then you would use, if you're using Jupyter Notebooks on your computer or Google Drive, you would use this by selecting the file path and putting it inside pd.read.csv. Okay? Because I read my GitHub reservoir, we'll just use the file that we have available to make our lives easy. Okay? So how many types of dinos are there? So let's just see how I'm understanding of our data set. So we have a data set on dinos today. Again, I worked very hard to get this, the data, a little bit of time travel and all. And so we have an equal number of dinosaurs that work very diligently to collect an equal balanced sample. Okay. So we can see what happens if we do a logic statement. We were talking about this in our presentations. We have dino equals to 1. We can see when dino 1 is true. So about a quarter of the time, it's going to be true. You see when it's true and it's false. Not super interesting by itself, but what we can do is we can use that to select out values of only the true cases. So only when this true cases, so we'll select out only these rows. So what we can do is we put this logic operation inside the first set of square brackets. Just like we use the first set of square brackets to select the name, what we're going to do instead, we're going to put a logic column, a Boolean column, into this, and what we'll do, you'll see here, we only get back 250 rows, so 25% of the data, the ones that are equal to 1, the dino is 1. So if we wanted to save this, what we can do is do this logic operation and go dot copy, and what we're going to do here is get the dino 1. Okay? And then we're going to get head here. Okay? And so if we look at that, now it only has the dinos that were 1, but now we have a reduced data frame of 250 rows of only dino number 1. Okay? So if we wanted to then get the average of the height of only dino 1, what we can do is take the average of the height column, dot mean, and get the average of that. So we filtered it down to just one dino, and then we can get the average of really anything pertaining to that one dino. If we wanted to use dual logical indexing, or wanted to do it based on certain sizes, okay? What we're going to do is, this works well for when we're looking for something in the middle. We're going to use and. So and, an ampersand here. So what we're going to do is, if it's greater than this value and less than this value. So we're looking for something in between, in the middle of the distribution. So it's good for using and. So it's greater than this value, less than this value, it's in the middle. Okay. So we do that, and we can see here, we're doing it 2 logic statements, equal to the column. We're creating 2 logic booleans, and this is only going to then produce 1 logic boolean, 1 column, that is when both of these are true. Both of these logic statements are true. Then we'll get a true output. If we then wanted to select a column after, we could use, so we're selecting the sizes of these animals, of these dinosaurs. We're going to, well, I guess they're technically dinosaurs or animals. So the dinosaurs, we can select that after. So notice here we have a data frame after we get back to data frame after we've done this, just like we saved a data frame up here. We get a data frame right here, and so we can work with it right away. So if we put square brackets right after that, we can go dot value counts, and we're going to get the value counts of just this dino column. So we're selecting this and then getting the value counts, just like we did way up above. Okay. So I just wanted to highlight this. It's really good. I found this out in the middle of class one day. There was an update and it changed. This is the only time I've ever heard of where and and ampersand are not equal and this is why I recommend using the ampersand, because this is a common thing that you'll do. So if you put the ampersand, it works, but the and symbol does not. Okay. So again, for pandas, just because it's important, everything else in Python does not matter because it's something that you'll do quite commonly in pandas. I would just recommend using the ampersand, and then you don't have to think about that. Okay. So I was looking for something in the middle of the distribution that have the t size of something in the middle. Here we're going to do which dinos have smaller than 5 length and greater than 20. So a tail length of greater than and a tail length of less than. So we're looking for the two extremes. We want to get the two extreme values here. So we're going to do that, and we're going to do this with the absolute value to do this. So only when one of these is true or the other one is true, which is good because we're looking for either tail, so that either it's really low or it's really high. Okay, so they're not going to both be true. Okay, so here we can put that dual logic statement into the first square brackets on our data frame and get back the rows where that is true. And then just like we did before, we can select, just to show you what this looks like. But I want to select just that column. So I have that same data frame that I create. I'm just going to select the dino column, and then I can run dot value counts on that and get the dinos that have the tail length that is greater than or less than. So we have dinos 1 and 3. You're curious to know which one's the true dinosaur names of those. Okay. So here, and just to show as well, the or written word does not work in this dual logic statement situation. So again, I just recommend sticking to the symbols for or and the absolute symbol and the ampersand just to do this. Okay, just showing that it does. Okay. So is one just little kind of quirk about pandas, but everything else. So thank you so much for joining me today, and I will see you next time.